in a logical place. Have you ever, here's the motivation for why we care about this. Have you ever called anybody a moron?
Yeah.
Or an idiot?
Yeah.
Or there's a third one, hang on. Moron, idiot, there's a third one, there's a third one. Wait, moron, idiot?
Ignorant.
No, not jackass or ignoramus. There's actually specific ones. Hang on. Well, do you know where those phrases come from? Do you know where those phrases come from? Hang on. No. Actually, there's historical reasons. Hang on. IQ level.
Sean, is it done? IQ level?
I don't think. Well, let's find out. I don't remember.
Stupido idiota.
No, these are the new ones. Hang on. There's old ones. IQ levels old. Oh wait, hang on a second. IQ levels idiot. I'll just put that in there.
Moron.
Imbecile. That was it. That was it. Imbecile. Moron, imbecile, and idiot. Yes, those are actually now. Here we go. Moron was IQ. Hang on. Where is it? Moron was an IQ. There we go. Between 51 and 70. That's a classification of a moron. I mean, and then an imbecile, 26 to 50. Idiot, 0 to 25. So you call somebody an idiot, that means a little bit more than it means call somebody a moron.
Wow.
Which to me actually seems backwards, just how I use the
Which
words.
means that it's within the first quartile.
Well, hang on now, hang on. That's a great question and or comment. So what I have some. I gotta turn this over to here. I've got it written down because I always screw this up if I don't write it down. Hang on, what am I doing with it? Here they are. Hang on, I have a question to ask you guys. Here we go. Now those phrases have changed. Those phrases have changed over the past 50 years. Those are like 1950s terms. So now we ask questions like this. What percent of adults are dull normal? Which is, I believe, I forget which range this used to be. It used to be called something like idiot or imbecile or something along those lines. So what I want to know is, what percent by definition, let me raise this up so you can see it a little bit better. Actually, I'll just do this. Yes, they're the new PC terms. We can't use idiot, moron. Yeah, I don't think you use genius anymore either. I think those terms are out. Gifted is the new PC term. So what I want to know is, based on this PC term, dull normal, what percent of adults are actually dull normal? They've got an IQ between 80 and 90.
So we can actually do it.
You can-ish. So Elena's saying, can we just use the normal? Well, you can kind of use the normal, but the problem is, let's grab our TIs for a second. Okay.
We have that will be backward.
Hang on now, let's think about this.
Okay.
More probabilities. What kind of problem would this be? Now, even though you might not see exactly how to answer it right now, you do know what kind of problem it is. Can you see this? Okay, you can. Why is it forward? Because I've given you numbers and I'm asking you to find the percent. I asked you to find the percent of adults between 80 and 90. So you don't have the area.
80, 90 was percent.
No, 80 and 90 are IQ scores.
Okay.
But watch this. But watch this, friends. Forward, between, type in 80 and type in 90. Now let it do its thing.
Oh. Oh.
Why is it 0? It's not 0, but why is it telling you 0?
It's almost.
But it's not in reality. There's actually a sizable chunk of dull normal folks out there. But why is this saying 0? When you put in 80 and 90, what is it thinking 80 and 90 are? What letter? Z's.
Yeah.
Which means you're 80 standard deviations away from average. That way. This is exactly the opposite of dull normal.
Yeah.
Correct? Dull normal should be over here. Right? Where's normal? Right there. We'll define normal momentarily, I promise you that. Dull normal should be over here somewhere. But when you put 80 and 90 into your TIs, it's sending it way over there. which is not where you want to be. So that's why your TI's program is called STA normal, or standard normal. An IQ scale is not standard normal, it's one example of general normal. Let's clear that up a little bit. Let me blank this. This is going to be your first example of a standard normal distribution. This does not mean we throw away the first example of a general normal. This does not mean we throw away the standard normal. No. We like him. We're going to continue to use him. The problem is he's too limited. The problem with him is that he assumes that whatever you're talking about has an average of 0 and a standard deviation of 1. Almost nothing has an average of 0. And even if it does, it hardly ever has a standard deviation of 1. So we need to be able to go back and forth between the standard normal, which is that beautiful thing in your TI, and the world around us, which is governed by general normal distributions. Were you guys amazed? I'm constantly amazed at this. When you were watching, I think it was video 1, the list of things that follow bell curves, I times with schizophrenic patients, volumes of gas tanks in cars, weights of M&Ms. I mean, so many things are bell-shaped. And we need to be able to go from those general, normally shaped things back and forth, distribution, back and forth to this beautiful standard normal distribution. Back and forth, back and forth. And the thing is, these things have averages and standard deviations, but they vary depending on the context. For example, I times with schizophrenic patients, times of eye contact with schizophrenic patients, they might average 1.5 minutes plus or minus 2.2 minutes. A volume of a 15-gallon gas tank in a car might average 15.2 gallons plus or minus 0.1 gallons. So these numbers are going to change, but we're going to have one more formula that'll allow us to go back and forth between this and this. And that's the last most important formula, I think, in the entire course. So here's the deal. All you've got to do is you have to know that things are bell-shaped. And here's the thing about IQ. IQ is bell-shaped. It's normally distributed data. And it's got an average of 100 and a standard deviation of 15. More on that in a second. IQ scores, the scores on IQ tests are bell-shaped. They are normally distributed. And by definition, they have an average of 100 and a standard deviation of 15. More on that in a second.
Has it been proved?
Has it been?
Proved.
You don't have to prove anything. It's human beings have made this up. Nothing. What is up for argument, I think, is what it means. I don't think it means squat. My personal opinion is that it doesn't mean squat. But there's nothing to prove because it's how we've set it up. Do you know what IQ stands for? Intelligence quotient. Do you know how they calculate it? Do you know why the average is 100?
I used to know.
And that's okay. It's okay to used to know because it isn't that. It's interesting in a trivial way. They take two measurements: your chronological age and your mental age, and they divide those two. Your mental age is in your numerator. Your chronological age is in your denominator, and the quotient of those two numbers multiplied by 100 to make it out of 100 is your IQ. That's why the average IQ is 100. If your head is as old as your body is, so to speak, you're average. I mean, that's what it means. That's what you would divide, get a 1-to-1 ratio. This is why young kids very often can get extraordinarily high IQs. Like if a 4-year-old kid takes an IQ test and tests like a 6-year-old, what's that kid's IQ? He's 150. 6 divided by 4 is 1.5 times 100 is, well, that's huge. Think about that. He's at 150. That's more than 2 standard deviations above average. That's more than 3 standard deviations above average. 3 standard deviations is 45. Above 100 is 145. That kid tested at 150. He's way out there in super genius land. But then again, there's a lot of variability in kids' minds when they're that young. And in order for me to get an IQ of 150, I'd have to test as, let me see, I'm 40. I'd test as a 60-year-old. I don't know what that means. Like, what does that even mean? You know? So that's what's up for argument, Elena. And I don't want to get into that argument in this class because I don't know how. I'm not qualified. But it totally is. And we can totally deal with this in this class as far as measuring the whole dull normal bit. So, here's the deal. Here's what we have. let's go over here a little bit. I'm going to use that board with the TI momentarily. But here's what we have. The question at hand. We have a bell curve. We have a bell curve. This is the IQ bell curve. What number is in the middle of the IQ bell curve? 100, the average. The average is 100 for the IQ bell curve, so it's going to be 100. Okay, the problem is, here's what we need to use. We need to use this curve, which has 0 in the middle of it. So that's one teeny tiny issue. Because the TI program that you guys just spent an hour learning how to use is called StunNormal, not JNormal. StunNormal has 0 in the middle of it. It also has standard deviations of 1, not 15, which is the other interesting component we have to kind of deal with. Don't worry, we'll get to this. We'll get to this. We'll get to this. We want to figure out the dull normal folks. Dull normal have IQs between 80 and 90. So they're like here to here, which is exactly where they should be with respect to that 100. Does that make sense? You see now what the problem was. What the problem was with taking 80 and 90 and putting them into StunNormal. It thought 80 and 90 stood for 80 and 90 standard deviations. That's like a 212-foot tall person. It's ridiculously off the charts. Like completely, arguably, impossibly off the charts for that matter. So what we need, friends, is we have a correlation now between the 100 and the 0. We've got to get from 100 to 0, which we know. What are you going to say, Hannah? You got something brewing over there. Go for it, my friend.
So it's pretty much the same. So like 0 subtract 10,
Oh, I love this.
and then like 0 subtract 20.
I love this. I love this. What we need to do
But
is go ahead.
it might be like in decimal.
Okay. It usually is. Let me make this color-coded so it's easier to see. It usually is, my friend. It's very rarely an exact z-score value.
Right.
And usually when they are, you know something's up. Let's just do this so it jumps out. So basically what Haley is doing for us, thank you, my friend, is she's giving us a transformation between where we are, these general scores, and the z-scores over there. So what we need to do is, we need to figure out what these two equate to over there. Does that make sense? What these two equate to over there, because we want to be able to slap up an area. Using all the colors today, this is great. We want to be able to slap up an area and shade it. And that area will be the same as that area. But this is the area you can get in your machine. You can't put this into your machine because I wrote it intentionally so you couldn't. Why? Because I'm a bastard? No, what kind of? I'm kind of a bastard. But I wanted you to make sure you could do this conversion. The conversion is one of the key parts of 244. Those of you going to 244 journey, that conversion back and forth is huge. I don't want to take all of it away from you. So let's develop the conversion. Haley, what's on your mind? Tell me what's on your mind over there. This is good.
I think it's -1 and -2.
Why?
Because I don't know really how to say, because since that's like 100 minus 9, like 100 minus 10 would be 90.
Okay, I love
And
this.
so it's like 0. You think of like the -1 and the -2.
This is so
as,
good.
like,
This
the
is so good. This is so
90.
good. I love this. Ready for this?
Um,
You've got it. You've got it. But it's not as pretty as -1. Me.
Isn't the standard deviation for 100 to 50?
That's the problem. Is you're trying to go by 10s, but you have to go by 15s. So check this out. Check this out. Check this out. Let's draw a second curve. I'm going to draw it here and then erase this. I don't want to draw it on these because it doesn't fit well. I didn't draw it well to fit there. Yeah. Putting Haley and Mimi's ideas together, we've got this thing dialed back. We've got this thing dialed back. So I'm going to swing it back over to here real quick. Let me ask you a real quick question before we go any further. If I was to shade that, what percentage would that be? You've already answered this question. You answered it about an hour and a half ago.
Okay, so
That's 68%, isn't it? Because that's one standard deviation. If the standard deviation is 15 on an average of 100, that's one standard deviation away from 100. So that's 68%. Fair enough? Beautiful. So now let's put Mimi's and Haley's ideas together to kind of see. And we could also bump it out 2 more, couldn't we? We could bump it out 2 more. I mean, we could do it, go down to 70 up to 130, 95%. And all that tells us is 95% of people have IQs between 70 and 130. That's a wide range. If you go out to 3 standard deviations, you got 9, right, exactly, from 55 up to 145. Now 99.7% of people have IQs there, and that's where this kid that has his IQ of 150, you're like, holy crap. Because he's outside of 3 standard deviations. He's in that very, very small percentage. Beautiful. But I think I'm going to tell you that today. But that helps us understand what you guys are talking about. Let me erase that, start again. Because I need to figure out a certain way. Here's 90, right? And here's 80. So we have to use this marking stick, this 15. It's definitely a marking stick, isn't it? So I'm going to go slap that 15. It's 85, right? So let's see, it's going to go 15 down to 85. Here's 80 and 90. It's going to go right there. So there's 15, correct? There's your 85. That's 1 standard deviation down. So that, from a raw score point, I'm going to do 2 scales here. This is starting to come together now. I'm going to call this X, and down here I'm going to call this Z. Because X is basically the raw scores we're starting with, and Z is going to be the number over there on that other curve. Now we know what Z score does 85 correspond to. What Z score does it correspond to? I've erased them all off the board now, unfortunately, although that will help us. -1, correct? That has to be -1. Let's do him in a different color.
Oh, because it's 1
down. Does that make sense? It's 1 away, but because it's 1 down, we have to call it -1.
Right.
So clearly 80 and 90 have to be negatives as well. And 80 is going to be -1 point something, and 90 is going to be less than -1. The question is, how much is it? Why 5? Or 0.5? Because that would mean, if it were -0.5,
yeah.
if it were -0.5,
Because it's in between 80 and 90 and...
is it exactly in between? Here's the question.
Probably not.
No, here's the question. Let's go with what you're saying though, Haley. This, how far apart are these?
5.
How far apart are these?
Oh, 10.
There's the problem.
Oh, the 15.
They're not, the 15's total, correct?
Yeah.
So how far down is it from 100? It's 10 out of the total 15. So what percentage of the way down is it? 2/3. It's 2/3 of the way down, right? If you're 15 out of 15 down, you're 1 standard deviation down. But we've only come down 10. So you're 2/3 of a standard deviation down. So this guy right here actually corresponds to -2/3. No, you weren't. You were not at all totally off. You were just off from a precision point of view, not an accuracy point of view.
Right.
Hold that thought. So what would this guy be? And if this is driving you nuts and making your head spin, we have tools to avoid the head spinning. It would be -4/3. It's 1 and 1/3.
Yeah.
It's 1 and 1/3. 1 plus 1/3 more. Every 5 points is 1/3 of a standard deviation. Think of it that way. If 15 is a full standard deviation, 5 points is 1/3 of a standard deviation. So every time you go down 5, you're picking up 1 more third of a standard deviation. That's why you've gone down 2, and this one is down 4. So now you know what you have to put into normal. You now know what you have to put into normal, because you now know what these numbers over here are. This is -4/3, and this is -2/3. Those are your normal endpoints, because you've done it strictly in terms of standard deviation. They're no longer, the context has been ripped from the curve and replaced with the pure measure of the standard deviation. If that doesn't make sense, don't worry. We have a tool that makes this much, much easier, I promise you. You don't have to go through this each time. I saw some fearful looks flashing around. We don't have to do that much mathematics, although I love what you guys did though. You went right to it. You said, okay, here's one where with respect to, yeah, it's exactly what the formula will do, but it'll do it for you without having to worry about it. So I'm going to take this off, replace it with the TI so we can answer the question. Let's see, blank screen, there we are. Is this forwards or backwards? Okay, definitely is forwards. More probs. Forwards. It's between. Rather than 80 and 90, negative 2/3, and you can put in fractions to see I can handle fractions. You can also change it to decimals if you want to.
Wait,
Oh, crap, put it in wrong, put it in wrong. Sorry, my bad. Forwards between negative 4/3, negative 2/3. That would have been a guaranteed error. It would have gotten confused.
And then what is that?
Here we go. Look at that. That's where it's supposed to be. That's where it's supposed to be, on the left of 0. So when you're looking at this, and that's negative 4/3 and negative 2/3 and 0, but it really is contextually 80, 90, and 100.
So what was the question?
The question was what percent of, exactly, exactly. This is where the formula will help, because 90% of our work right now was getting those z-scores. The question was, what percent of adults fall between 80 and 90 on the IQ scale?
About 16.
About 16% of them. Roughly 16% of them fall between 80 and 90. Which means about 16% of them also fall between 110 and 120.
Oh.
Over here as well, right? There's a corresponding strip over here. I guess that would be like bright normal, not dull normal. Bright normal. Sure. Yeah, sure. Ish. Does that fair? Is that fair-ish? Now, what I love about what Mimi and Haley just did was you guys invented the formula I'm about to show you. There's only one more formula I want to talk about in this course, and you guys just developed it yourselves, which is freaking awesome. It's called a z-score conversion formula, is all it is. It's a way to take these numbers on this curve and make them be the numbers we need on that curve over there. And like I said, you guys already have it, which is fantastic. So let me mute this, and let's take a look here. I'm going to put this on this board. And you see how I have these arrows going back and forth? We have to be able to fluidly go back and forth between them, and this formula allows us to do just that. To go back and forth between them. What's the best place to put this? Let's just take the IQ thing out. We have that written down. To get a z-score.
So is this for both of the standard
Yes.
now?
Depending on what you need, you may have to solve it for a different variable. We'll see that more on Wednesday of next week, but you may have time to do one more, so you have to solve it for a different variable today. But we needed the z-scores in this example, correct? We needed to take the raw scores, which I was calling x's, and convert them to the z's that go on the standard normal curve. So in order to get the z-score that you need to get a conversion for, you take the raw score, whatever that raw score is, subtract the average, which will be given to you, which will be known, and this is the tricky part. You guys figured this out. Divide by the standard deviation. That's what you guys were doing. That's what you were doing. You don't realize it, but remember when we said, how far down is it? Oh, it's 10 down. And then we divided that by 15 and said that's 2/3 of a standard deviation. That's what you did.
For example,
Yes.
in our situation, can
Yes.
you check?
Sure. 80 minus 100
Mhm.
divided by 15.
Uh-huh.
80 minus 100, negative 20,
Mhm.
divided by 15, negative 4/3.
But-
See, 80 and 90, these are our raw
Oh,
scores.
so
The
then
80
you
and
put
90 are our raw scores.
90.
Exactly. So that was the 80, so the other one was
90.
90 minus 100, negative 10,
Mhm.
divided by 15, negative 2/3.
So, and then we'll have just two numbers, right?
Right, or sometimes one. Never more than two. If you're only doing, this is a between problem, you could be doing a left or right problem as well.
So, the z-score will be like negative whatever, negative.
Sure, sure.
But how, but the question is the percentage, so.
Well, that's where the TI comes in. You run the z-scores through the
I see,
TI and
I
it gives
see.
you the
So
percentages. All this does, all this formula is doing is, it's getting you set up to use the machine I gave you, to know what to put in the machine I gave you. Is that fair?
Yeah.
That's all it's doing. And that was what the lion's share of the work we just did was. Think about it, friends. Once we had the z-scores, you had the machine on and the answer had in 30 seconds. But it took so long, Hallie had to ask, what the hell was the question again? Because we took so long futzing through figuring out what the z-scores were. This is exactly why we have mathematical formulas, to prevent us from having to do all that inordinate amount of work. Now you've got it. We'll use it in good health. We'll use it in good health. Please, Rach.
So instead of having it in fractions, can we put it in
Oh, of course, negative 0.67, I guess, and negative 1.33, sure. You might get disagreement to area in the fourth decimal place or something, but don't sweat that. This class is all about ish anyway. Yeah, totally, use decimals if you want to. Is that fair? Now, technically, but because this formula is the way it is, by definition, you have fractions. I mean, it's a fraction itself. But by all means, use the decimals if you want to. Yeah, for sure. Cool?
Cool.
Let's find another, let's do one of the moron one. What was that one? That was a good one. Let's figure out, that was the dull normal. I erased it. Shh. Hang on.
I remember 51.
Let's figure out IQ level moron. Here we go. What was that? Moron psychology, Wikipedia. Moron between 51 and 70.
Yeah.
Go give me the morons. What percentage of people are morons? What percentage of people are morons? They have IQs between 51 and 70. We're going to put that. We got this one all right. You can take this out here. I'll shut the camera down for now.